In this video, we're going to be doing a couple examples about how to find the area of a circle. And whenever we want to find the area of a circle, we always use the formula A, or area, is equal to pi r squared, where r is the radius of the circle. So when we have a problem like this one, for example, we're told the radius is equal to 6. All we have to do is plug 6 in for r and get our area. So A, area, is equal to pi times 6 squared. 6 squared is 36, so we get 36 times pi. Now sometimes you'll be asked to give a decimal or a fractional answer instead of an answer in terms of pi. If you're asked for an answer in terms of pi, you want to go ahead and leave pi in the answer. If you're asked for a decimal answer or to round to the nearest tenths place or hundredths place, you want to use an approximation for pi of 3.14. If you're asked for a fractional answer, you'll want to use an approximation for pi of 22 over 7 and multiply that by, in this case, 36, and leave it as a fractional answer. But in this case, in this video, we're going to leave all of our answers in terms of pi. So the area would just be 36 pi. What about if we're given an example like this one, or a problem like this one, where the diameter of the circle is equal to 18? Well, the diameter is the full width of the circle. The radius is half the width of the circle. So if I have a diameter of 18, that means I have a radius of 18 divided by 2, or a radius of 9. And if my radius is 9, then I can just go ahead and plug into my area formula to find the area. So pi times 9 squared. 9 squared is 81, so I'm going to get 81 pi. Now, it's really common to be given problems like these ones where you're asked to find the shaded area. In this first example here, we have a circle. We know that the diameter of the circle is 8, and we need to find the area of half of the circle, this shaded area here. Well, again, we want to come back to our formula. We always need radius. So with all these kinds of problems, you're always thinking radius. What's the radius? Well, the diameter is 8. Half of the diameter is the radius, so the radius is going to be half of 8, or 4. So in this case, area is going to be equal to pi times 4 squared, or area equals 16 pi. But remember, that's the area of the entire circle, and we only want half of the circle because that's the portion that's shaded. So what I have to do then is divide this by 2. 16 pi divided by 2 gives me 8 pi, so the area of the shaded region then is 8 pi. What about this example here? We have a circle, and then we have a smaller circle inside of it, and we want the area between the two circles. Well, the easiest way to tackle a problem like this one is to find the area of the entire circle and then subtract out the area of the smaller circle, which will leave us with just this shaded ring. So we've been told that the radius of the larger circle is 9, so we're going to go ahead and calculate the area of the full circle. That's going to be area equals pi times 9 squared, or area equals 81 pi. So 81 pi is the area of the entire circle, but we don't want the area of this smaller circle included. So what's the area of that? Well, the radius of that smaller circle is 4, because remember, this is our center, and this is to the edge of the smaller circle, and we've been told that that distance is 4. So the area of that smaller circle is going to be area equals pi times 4 squared, or area equals 16 pi. So then, to get just the shaded area, I'm going to say 81 pi minus 16 pi is going to be equal to 65 pi, and that'll be the area of the shaded region. Let's try a couple more complicated examples. In this one, we've been given a rectangle, and it's hard to see, but we've been told that each of the 4 corners is a 90-degree or a right angle. So we know that this is a rectangle, and we have 3 congruent circles, 3 circles of equal size inside of the rectangle, and they go edge to edge, left to right, and edge to edge, top to bottom. So remember, when we're dealing with area of a circle, we're always thinking radius, right? So what we need to figure out is the radius of each one of these circles. So what we can realize here is that we have basically 1 radius, 2 radii, 3 radii, 4 of them, 5 of them, 6 radii across to get the entire width of the rectangle. And we know that the width of the rectangle is 60. We've been given that. So what we can say then is that 60 is going to be equal to 6 times the radius of each one of these circles. If I divide both sides by 6, I'm going to get radius is equal to 10. So the radius of each of these circles is going to be 10. So what do I want to do since I want the shaded area? I want the area inside the rectangle, but not the area of the circles. Let's first find the area of the rectangle. Well, we know that its width is 60. What about its height? Well, we just found that the radius of each circle is 10. So not only is the horizontal radius 10, right, but the radius is the same all the way around. So this means that this distance is 10 and this distance is 10. So when I add those together, I can see that the height of the rectangle is going to be 20. So the area of my rectangle is going to be 60 times 20, right? Base times height, which is going to be equal to 1,200. So the area of the entire rectangle is 1,200, but now I need to subtract out the area of all three of my circles. So let's go ahead and find the area of one circle and then multiply it by 3 to get the total area of all three circles. So the area of one circle is going to be pi times the radius squared. Well, the radius is 10, so I'm going to get 10 squared, and then I'm going to get 100 pi. If I want the area of all three circles, I'm going to multiply both sides by 3, and I'm going to get 300 pi for the area of all three circles. Now, since I just want the shaded area that's inside the rectangle but outside the circles, I can say that the area I'm interested in is going to be 1,200 minus 300 pi. And again, if you used 3.14 for pi or 22/7 for pi, you could approximate this in decimal or fraction form, but we'll go ahead and leave it in terms of pi. For our last example here, we have something that looks a little bit like a basketball key. We have this rectangle here with 4 90-degree angles at its corners, and then a circle that overlaps it. So the easiest way to go about doing this problem is to first find the area of the rectangle. So we'll go ahead and find the area of this rectangle right here, and then we'll find the area of the half circle that lies outside of that rectangle and add them together. So the area of the rectangle, we've been told that its dimensions are 12 by 20. So the area of the rectangle is going to be 12 times 20, which is going to give us 240 for the area of the rectangle. Now, what about the area of the circle here? Well, remember, when we're trying to find the area of a circle, we always have to think radius, and we don't have a radius yet. However, we know that this measurement here, the height of the rectangle, is 12. And of course, that's the height of the circle as well, which means the diameter of the circle is 12. The radius is always half the diameter, which means the radius has to be 6. So I can go ahead and say that my radius is 6, and therefore that the area of the entire circle is going to be pi times 6 squared, or 36 pi. But again, that's the area of the full circle, and I don't want to include the inner half of this circle because it overlaps with the rectangle, and I've already included that area in my 240 square units right here. So I only want to include half of the circle's area. So I divide this by 2, and that's going to give me 36 divided by 2, 18 pi for the area of half of the circle. So then I can say that my total area is going to be 240 plus 18 pi. And those are just a couple simple examples about how you can find the area of a circle.